Hello students, welcome to the CBSE lecture series. So, in this particular CBSE standard 11th and 12th in the chemistry textbook, first today we are going to take 12th standard second chapter solutions. First of all, we have to know what is a solute and what is a solvent. First, we have to think about what is a solution. Solution is a combination of solute and solvent, which is nothing but solution. Now, we have to define what is meant by solute. Suppose in a mixture of solutions, if there is a two components, one component is present in a lesser quantity. That lesser quantity we can call it as solute. One which present in a larger quantity, then it is called solvent. If solute and solvent mix together, we can call it as a solution. Suppose if it is a two components in a mixture, then it is called binary solutions. If it is a three components present in a mixture, then it is called a trinary solutions. If it is four, then it is a ternary solutions, and so on. In that solution lesson, we are going to discuss about expressing the concentration of solutions. Expressing the concentration of solutions. We can express the solutions in various terms, like one is a percentage, second one is a molarity. See the spelling MOLARITY. It is denoted by the letter M. Third one is a molality. MOLALITY. It is denoted by the small m. Then the next one is a mole fraction. It is denoted by the letter chi. How can you pronounce this letter? Chi. Then the last one is known as ppm, that is nothing but parts per million. So, we are going to discuss all this type of concentration of solutions expressing in different ways. One is a percentage, molarity, molality, mole fraction, and ppm. Let us discuss one by one. Okay. First, let us start a percentage. What is a percentage? Percentage, if it is a two components, one is a solid one, that is a solute, and solvent, both are present in as solids. Then we have to say weight by weight percentage, weight by weight. So, suppose if you want to find out a mass percentage of solute, mass percentage of solute means weight of a, so in this case solvent we can express as a 1 and solute for our representation 2, or sometimes you can use A or B. If a mass percentage of a solute means it is a mass of a solute, you can use a letter 2 or you can use B or something else, we can fix any one. So, for that mass we can use the letter W2. Then total mass of solute and solvent, total mass of solute and solvent. Mass percentage is there, you got to into 100. This is a formula for finding the mass percentage of solute. Mass percentage is nothing but mass of a solute divided by total mass of solute and solvent into 100. Suppose if you want to find out a mass percentage of solvent, how can you find out this one? W1 by W1 plus W2 into 100. If we express in terms of what? Words, mass of solvent divided by total mass of solute and solvent into 100. That is a method of finding the mass percentage of solvent. Now let us discuss second one, molarity. M-O-L-A-R-I-T-Y. It is denoted by the letter capital M. How can you define the molarity? Molarity is defined as it is the number of moles of solute. Number of moles of solute in grams by volume of the solution. Volume of the solution expressed in liters. Same thing we can convert in the form of formula. Molarity is equal to number of moles. We can use the letter suffix N2. Solute already we fixed as a 2 and number of moles is denoted by the letter small n. Volume is what? V, capital L liter. Then already we know that number of moles is nothing but given mass by molar mass, or if it is used at N2, W2 by M2. What is W2 and what is M2? Mass of solute by molar mass of solute. So you have to express in this formula M is equal to, in the place of N2 you can substitute W2 by M2 into, suppose if the volume is expressed in ml, milliliters, then you have to 1000 divided by VML. This is the formula. Now we can say define all the terms. M stands for molarity, W2 stands for mass of solute, and the capital M2 is what? Molar mass of solute, and V stands for volume of the solution, S. Suppose if it is asked in the problems, you can use the formula and substitute the values, you will work out the problems. So that we will discuss separately as a by taking one examples. Now let us discuss molality. It is denoted by the letter small m. What is the molality? Molality is defined as it is the number of moles of solute, number of moles of solute in grams divided by mass of solvent expressed in kilograms. Total mass of solvent expressed in kilograms. What is the molality? Molality is defined as it is the number of moles of solute in grams to the total mass of solvent expressed in kilograms. If we convert in the form of formula, M is equal to number of moles of solute N2 by W, solvent we fixed as a 1, so you have to put 1, and kilogram kg. Further you have to modify this one. N2 is what? Nothing but where N2 is equal to W2 by M2. N2 is what? Mass of solute divided by molar mass of solute. So W2 by M2. If we express in grams, then it is 1000 divided by W1 G. This is the formula of calculating the molality. See the spelling M-O-L-A-L-I-T-Y. So molality is defined as it is the number of moles of solute in grams to the total mass of solvent which is expressed in kilograms. So this is the formula of calculating molality. Yes. Now let us start mole fraction. Mole fraction we can express in terms of the letter chi. How can you read this? It looks like X, but you have to read like chi. Mole fraction is defined as, if it is a chi 1, then you have to say N1 by N1 plus N2. What is the mole fraction of 1 means solvent, 2 means solute. So if you want to calculate the mole fraction of solvent means number of moles of solvent divided by total number of moles of solute and solvent. If you want to find out for chi 2, then you have to say N2 by N1 plus N2. 1, or you can say A, this is a B, the another one C. If it is a binary solutions, chi1, chi2 is always 1. Here you got to think about N1 is nothing but W1 by M1, where N2 is equal to W2 by M2. So, wherever we want to solve the problems, then you got to use the formulas. So, this is a method of calculating mole fractions. The final one is ppm, parts per million, parts per million. Where we are using these parts per million, we can normally using in that drinking water, normally we can call it as what? Mineral water. Certain minerals we need for our healthy life. So, in that mineral water, say for example, iron, calcium or iodine, this type of some minerals will be present in terms of very minute quantity. That term we can use or express in terms of parts per million, or in sometimes in the medicine syrups. If we happen to see that medicine syrups compositions, there they are using the ppm word, that is nothing but parts per million. Suppose if there is a many number of components present in the solution, means if you want to express as a parts per million is nothing but number of mass of one component, mass of one component divided by total mass of all components, total mass of all components. If it is a 10 components or more than 10 components, whatever the number of components, into 10 to the power of 6. 1 million is nothing but 10 lakhs. For 1 lakh it is 5 zeros, 10 lakhs is what? Totally 6 zeros. So, 10 to the power of 6. So, this is the formula for calculating the parts per million problems. Suppose normality, it is not expressed in your textbook, even though you have to know what is the normality. Normality is also one kind of way to express the concentration of solutions. So, what is the normality? It is denoted by letter capital N, is nothing but number of gram equivalents, number of gram equivalents in volume of the solution. Yes, number of gram equivalents of solute expressed in volume of the solutions liter. Suppose if we express in terms of formula, so N is equal to W2 mass of solute divided by equivalent mass of solute, equivalent mass of solute into 1000 divided by VML. So, this is the formula for calculating normality of a solutions. So, in the expressing of concentration of solutions, there are different terms are there. One is a molarity, molality, percentage, mass percentage, then mole fraction and parts per million, and finally normality. So, once we know all these things, we will discuss one by one with examples to solve the problems. Yes students, now we will take one example to solve the problems. So, previously we discussed all the terms like molality, molarity, mole fractions. These all are involved in one problem. So, we will take one by one and we will solve it. So, in this particular problem, I will read out the problems. Calculate molality, molarity, mole fraction of potassium iodide. If the density of 20% by mass aqueous solution of Ki is 1.202 gram per milliliter. So, this is the problem given. First, we will write a data, given data. See that one. So, 20% by mass they are given. Then you have to use, already I told you, 1 for solvent and 2 for solute. Mass of solute is expressed in terms of what? Grams. So, W2 is equal to 20 grams. What is W1? If it is a total, is a percentage, means 100. 100 minus 20 is nothing but 80. So, that is what? Mass of solvent is 80 grams. Then what are given? So, density is given 1.202 gram per milliliters. That is all the data is given. And suppose this W2 is what? Ki. So, we can calculate the Ki. The atomic mass of K is 39 and I is 127. If we add these two things, we can get 166. That is the molar mass of Ki. And what is the molar mass of water? Because it is dissolved in water only, aqueous solution means water. So, H2O, it is nothing but 2 plus 16 equal to 18. So, the question calculate molality is given. So, we will discuss. Can you remember the formula for molality? Molality, that is denoted by the letter small m, is nothing but W2 by M2 into 1000 divided by W1 grams. This is the formula for calculating molality. The first question is molality. So, here already is defined as what? W2 is given as a 20 and molar mass of solute is what? 166 into 1000 divided by what is W1 here? Yes, 80 grams. So, just you have to cancel it, 10 10 cancel. Now, we will see here, I substitute the values. If you 0 cancel, 20 into 100, that is what? 2000, 166 into 8, 1328. If you simplify it, we are getting the values 1.5. So, that is nothing but moles per kilogram, or simply you can say small m, molality small m, that is it's enough. Yes. Now, we can discuss the second part. The second part is what? Calculation of molarity. Calculation of molarity. Already know that molarity is nothing but number of moles of solute, that is W2 by M2 into 1000 divided by V ml. This is the formula for calculating molarity. Here V is not given directly. So, you want to use the formula here. In this case, density is equal to mass by volume. If you want to find out the volume, that is what? Mass by density. Mass is 100 by density is given as 1.202. This you have to substitute in this one. So, W2 we know that what? It is 20 grams. 20 divided by what is the molar mass of solute? It is 166 into 1000 divided by, in the place of V, volume of the solution, you want to express 100 divided by 1.2, that is what? Come to upper side, 1.202 gram per milliliter. So, if you cancel all these things, 20, okay. If you simplify it, yes. Now, if you substitute all the values in this formula, W2 is what? Mass of solute is 20, molar mass of solute, molar mass of Ki is 166 into 1000 divided by that volume is what? 100 into 1.202. If you multiply this one, 240.4 divided by 166. If you simplify it, 1.44 m. If you put a capital M, M stands for molarity. In the third part, calculation of mole fraction. Calculation of mole fraction of Ki they are asking. Ki is a solute here. So, mole fraction is denoted by letter chi. If it is a solute, Ki is what? Chi2 is nothing but N2 by N1 plus N2. This is a formula for calculating mole fraction of Ki. So, where N2 is nothing but W2 by M2, that is N2. Okay, you can substitute one. W2 mass of solid is nothing but 20 grams by molar mass is 166. If you simplify it, it is 0.120. Okay, that is a mole. At the same time, if you express by N1, that is W1 by M1, that is nothing but what is the mass of solvent? 80 grams divided by what is the molar mass of water? It is 18. If we simplify it, what will happen? It is 4.44 mole. Now you can substitute these values in this formula. So Chi2 is equal to, what is N2? Here already we find out as 0.120 divided by total number of moles of solute and solvent, that is 0.120 plus 4.44. If you add these two things, 0.120 divided by 4.56. Further you can simplify it, we can get the answer 0.0263. This is the number of moles of mole fraction of solute. Suppose if the question is what? Mole fraction of solvent. How can you find out? Chi1, if they are asking, means you have to use the formula Chi1 plus Chi2 equal to 1. Then the another formula is what? Chi1 plus Chi2 is equal to 1. Already we know what is Chi2. So Chi1 plus Chi2 is what? 0.0263 equal to 1. Then Chi1 is equal to 1 minus 0.0263. If we substitute what? If we subtract this one, we can get 0.9737. That is a mole fraction of solvent. So in a sample problem or in a example problem, all the three want to calculate it: molality, molarity and mole fraction of Ki. So all are discussed here. Once again I will tell you, the data given is what? Mass of solute is 20 grams, then that mass of solvent is 100 minus 20 is, which is 80 grams. D density is given 1.202. Then M2 for Ki is what? You have to calculate the molar mass of solute, that is a Ki. Potassium atomic mass is 39 plus 127, which is 166. Then molar mass of solvent, that is water, 18. If you molality, use the formula small m is equal to W2 by M2 1000 divided by W1. If you substitute that, mass of solute is 20 divided by 166 into 1000 divided by 80. If we simplify it, we can get the answer 1.5. If you want to calculate the molarity, you can use the formula molarity is equal to number of moles of solute divided by volume of solution in liters. 20 divided by 166 into 1000 divided by 100. That is said, you have to use the formula density is equal to mass by volume formula. If you want to find out the volume, mass by density, mass 100 divided by 1.20. So if you substitute here, answer is 1.44 m. At the same time, if you want to find out a mole fraction of calculation of mole fraction of solute, that is potassium iodide, Chi2 is what? N2 by N1 plus N2. If you substitute, if I separately, you have to find out first what is N2, what is N1. If you substitute the values here, we are getting the value of Chi2 is equal to 0.0263. If you want to find out a mole fraction of solvent, you can use another formula Chi1 plus Chi2 is equal to 1. The Chi1 is what? 1 minus Chi2, that is 0.9737. So if you have any doubt, you can ask the comment box. We will discuss that one. So I will give one example as a homework. You can work out and things. Thank you. Hello students. So now you can see the problem for practice. So you can take it as a homework and work out it. If you don't know things, I will work out the next class, or you please mention the comment box. Calculate the molality and mole fraction of 2.5 gram of ethanoic acid. Its formula is CH3COH in 75 gram of benzene. Benzene formula C6H6. So you have to calculate molality and mole fraction. The second one problem. Calculate the molarity and normality of a solution containing 5 gram of NaOH in 450 ml of solution. So in this question, you have to calculate molarity as well as normality. So here solute is given as a 5 grams NaOH. So you have to calculate what? Molar mass of NaOH. Na is 23, oxygen 16, hydrogen 1, so totally 40. In 450 volume is given, so you can easily find out, use the formula and find out the answer for these two problems. Thank you students.